Now, we're going to take up one more problem, the problem number 56. The vertical rods, one of steel and other of copper, and each rigidly fixed at the top and 500 mm apart. A crossbar fixed to the rods at the lower ends carries a load of 5 kN such that the crossbar remains horizontal even after loading. Area of cross-section of steel rod is 1000 mm square and that of copper is 1500 mm square. Length of steel rod is 5 meters and that of copper rod is 2.5 meters. Find the stress in each rod and the position of the load on bar. Take Young's modulus of steel, which is ES is equal to 2 into 10 to the power of 5 Newton per mm square, and Young's modulus of copper, which is EC, equals 1 into 10 to the power of 5 Newton per mm square. So this is the actual problem wherein you have a copper bar and the steel bar which are kept 500 mm apart, and the length of copper is 2.5 and the length of steel is 5 meters. And the load applied is 5 kilonewton, which is at some distance, which you need to calculate so that it is going to remain horizontal. So now, first stresses in each rod we need to find out. For static equilibrium, what is that? PS plus PC will be equal to the total load, which is 5000 Newton. What is PS? PS is nothing but sigma S into ES plus sigma C into AC will be equal to 5000 Newton. Now, since the bar remains horizontal even after loading, so delta LS will be equal to delta LC, which is equal to PS into LS by AS into ES will be equal to PC into LC by AC into EC. So what is PS by AS, which is nothing but sigma S into LS by ES will be equal to PC by AC is nothing but sigma C into LC by EC. So sigma S into length of the steel bar is 5000 divided by Young's modulus is 2 into 10 to the power of 5, which will be equal to length of copper, which is 2500 into sigma C by 1 into 10 to the power of 5. On simplification, sigma S will be equal to sigma C. So therefore, substitute the value of sigma S and sigma C here. So sigma S into area of steel is 1000 plus sigma S. Sigma C is nothing but sigma S. So substitute the value of sigma C as sigma S into AC is 1500 will be equal to 5000. So stress induced in the steel rod will be equal to, on simplification, 2 Newton per mm square. What is the stress induced in the copper rod? The stress induced in the copper rod is sigma S will be equal, sigma C will be equal to sigma S will be sigma S. So therefore, that is also equal to 2 Newton per mm square. Now, what is the position of the load? The position of the load on the steel rod will be equal to PS, which is sigma S into ES. So 2 into 1000 will be equal to 2000 Newton. Similarly, load on the copper rod will be equal to sigma C into AC, which will be again 2 into 1500, which will be equal to 3000 Newton. So taking the moments about the point A, that is PC into 500 will be equal to 5000 into X. So you know the value of PC, which is 3000. So 3000 into 500 will be equal to 5000 into X. Therefore, the value of X is equal to 300 mm. Hence, the applied load is 300 mm from the copper rod or 200 mm from the steel rod. This is how you will be able to solve this problem. So we will take up one more problem, that problem number 57. A composite bar of steel and copper is fixed between two rigid supports and loaded as shown in the figure. So here, one is the steel and the other one is the copper, which is being fixed through the rigid supports, this is the rigid support at A and B. If the load is applied axially, find the point at which the load should be applied to have the bars carrying equal loads. E for copper is 100 GPa and E for steel is 200 GPa. So we have the load which is applied here, which is L2 and L1. So that we need to find out. So to do that, and the overall length of the member is 3 meters. So here, first EC is equal to 100 GPa, that is 1 into 10 to the power of 5 Newton per mm square. ES is 200 GPa, which is 2 into 10 to the power of 5 Newton per mm square. Total load applied P will be equal to 10 kilonewton, and length of the steel on the brass bar will be 3 meters, which is 3000 mm. So let L1 be the length of the copper and L2 be the length of steel. Therefore, length of steel bar will be equal to 3000 minus L1. So assume the diameter of the copper and is equal to the diameter of the steel. So AC is equal to AS. So if RA and RB be the reactions at the ends, then the copper bar will be under tension, steel bar will be under compression. So that is what he says. So once the load is applied here, so this is the rigid support. So when you take up the copper will be in tension, and when you take up the steel rod will be in compression. Because to this section, if you are considering the copper and the load is applied to the right of the section, so naturally it becomes tensile, which is positive. When you are taking the steel rod, one end, the right end is fixed. Now we are trying to apply the load from this direction, so naturally it becomes compressive in nature. So that is the reason why he has still well tension, steel bar will be under compression. So what is the equilibrium of the bar? RA plus RB will be equal to 10 into 10 to the power of 3 Newton. So as the bars are carrying equal loads, RA will be equal to RB, which is equal to 5 kilonewton. So also what is the elongation of the copper bar will be equal to elongation of steel bar. So delta LC will be equal to delta LS. So delta LC is nothing but PC into LC by AC into EC is equal to delta LS PS into LS by AS into ES. So what we know is PC is equal to RA and PS will be equal to RB. Therefore, and AC is equal to AS. So LC is equal to L1. So LS is equal to L2. So naturally, substitute all these things in this equation, that is PS into LS by AS into ES. So what is PS? PS is nothing but RA. You substitute that. What is LS? LS is nothing but L2. L2 by EC. PC is RA. PC is RA into length of the copper bar is L1 by EC will be equal to PS is nothing but RB into length of steel is LS is L2 by ES. So on simplification, L1 by 1 into 10 to the power of 5 will be equal to what is RB, which is 3000 minus L1 by 2 into 10 to the power of 5. So therefore, that is because RA will be equal to RB, so it will go to be get cancelled. So on simplification, cross multiplication and simplification, 2L1 plus L2 will be equal to 2L1 plus L1 will be equal to 3000. Therefore, therefore L1 will be equal to 1000 mm. So length of copper bar, which is L1, will be equal to 1000 mm, and length of the steel bar, which will be L2, which is 3000 minus L1, which is equal to 2000 mm. Therefore, it is equal to 2 meters. So this is how you will be able to solve this particular problem. If you find this if you find this video is useful to you, please subscribe to my channel. Thank you.